In exercise 122, in the video that we made for that, we went through a whole long explanation, and what we came up with was this sort of shorthand. So if you can remember this shorthand, that if you have all sigma bonds, if a carbon atom has all sigma bonds, it's sp3 hybridized. If it has one pi bond, it's sp2 hybridized. And if it has two pi bonds, it's sp hybridized. You can use that little summary to identify the hybridization state of any carbon in a molecule. So, for example, we can look one carbon at a time. You would want to remember that the first bond you ever form between atoms is a sigma bond. So this bond here would be a sigma bond, this bond here would be a sigma bond, and the first bond between these two carbons would also be a sigma bond. Every bond after the first bond is a pi bond. So that purple bond there would be a pi bond. And you can see that around this carbon there is only one pi bond. Only one pi bond. If you have only one pi bond, the carbon is sp2 hybridized. So this carbon here is sp2 hybridized. Moving on to the next carbon, we look here. The first bond you ever form between atoms is a pi bond. Is a sigma bond. So that is a sigma bond, this is a sigma bond. Every bond after the first bond between two atoms is a pi bond, so that's a pi bond, and this is a pi bond. So here you have two pi bonds, and from our little table, we can tell that if you have two pi bonds, the carbon that has those is sp hybridized. So this carbon is sp hybridized. If we move to the next carbon, you would see that you've got the first bond between two atoms is a sigma bond, so these first bonds between these two atoms are sigma bonds. Every bond after the first bond between two atoms is a pi bond. So here the second bond between those carbons is a pi bond. And you can tell that around this middle carbon we have two pi bonds. Now if you ever have two pi bonds, the carbon that has those is sp hybridized. That's what the conclusion we came to in the previous video. So here, this carbon here is going to be sp hybridized. Then we can go to this carbon on the far right. The first bond that forms to any atom is a sigma bond. So this first bond between these atoms is a sigma bond. First bond between these two carbons is a sigma bond. Every bond after that first bond is a pi bond. So this right here is a pi bond. So around this carbon here, you can see that we only have one pi bond. And so that carbon is going to be sp2 hybridized. So sp2 hybridized. And that would be the hybridization for the carbons in that molecule. Let's do the same thing to B. So this is the last molecule for this exercise. So we're only interested in the carbons. Let's start with this top carbon. The first bond you ever form between two atoms is a sigma bond. So the first bond between that carbon and the oxygen, sigma bond. Every bond after the first bond between two atoms is a pi bond, so that second one is a pi bond. How about on the other side? The first bond you form between these two carbons is a sigma bond. Every bond after the first bond you form between two atoms is a pi bond. So if we're looking at this carbon right here, that has 2 pi bonds around it. And if you have 2 pi bonds on a carbon, the carbon is going to be sp hybridized. So that carbon is sp hybridized. How about the carbon at the bottom? This carbon here. So that carbon, well, let's look at the bonds. The first bond you ever form between two atoms, sigma. First bond you ever form between two atoms is a sigma bond. First bond you ever form between two atoms is a sigma bond. Every bond after the first bond is a pi bond. So that's a pi bond right there. So if we're looking at this carbon here, we can see there's only one pi bond around it. And if you have only one pi bond around a carbon, it is sp2 hybridized. So that carbon there would be sp2 hybridized. And what these hybridizations are going to let us do is predict the right shapes for these molecules. That's what this is leading to. These hybridization states will tell us what the shape around that carbon is. And so you can find the hybridization states with this little table that we made.